opportunity to discuss with you all about human spaceflight research and international space station experiments. So it's like being in a human test as a like a subject, developing the safeguarding. The effects of spaceflight often requires human subjects that support the data collections of researchers, and they needed to wanted to know about how astronauts like possible, and either you can accomplish by different type of experiments and missions. It's like, during the COVID-19 situation, as everyone been suffering like isolation analogs, it's like a nearly a year. So in the similar way, the analog astronaut trainings are will be like isolation analog, something like that. There will be like the humans capsizes why they use the analog missions, because they're going to to the space. It's very quite expensive, and sometimes you may not be able to manage to organize the experiments. So you have to make sure the systems are ready and working conditions, so that will be deployed in International Space Station or flying to Mars or Moon or something like that. So why the human space flight researchers like human exploration research analogs? These are like analog missions, that is prepare yourself in near term or like future explorations. For example, like if you are going to asteroids, or you are going to flying to Mars, flying to the moon or something. So for that you have to create yourself and make yourself ready, and to prepare the significant ideas. Like for example, like you wanted to problem solving capabilities, something that you need to improve. So mostly not all the experiments that can be done in space, but there will be like the limitations, maybe the money and time and the equipments and the manpower, and there will be like a countless of measures that can be needed tested before you needed to try to them yourself put himself into space. So there are issues are happening. There will be like numerous tasks that you need to develop on it, so that you have to prepare yourself. For example, like a ground-based analog studies that completely very quickly and less expensive. For example, in general, what are all the analog missions like? You can look at here analog missions are different field tests. That location is like the physical similarities. For example, like a Mars means Mars like look like a terrain, and they use try to find the extreme space environments actually. The NASA engineers and even engineers and the Indian Gaganyaan mission also they are planning. So there are like several government agencies and private players and industries. They are coming together to start working on to study in this harsh environment. Some of the tests on testing the new technologies, testing the robotic equipments and vehicles, habitats, communications, and power generation, and mobilities. And you can go about the infrastructure, lunar buildings, building the structures on Moon and Mars, and you have to storage and behavioral effects such as something like isolation. When you are in isolation and confinement, how you behave. Or there will be like a team dynamics, and there will be like a fatigue, stress, and those things have been observed like human engineering. Mostly the hazards to the analog missions in general. The spaces should like unfriendly place, and only one goal is to mostly the analog missions is like look like to safeguard the hazards that life in space. What exactly these are the hazards? There will be like we have to categorize into the five classifications like space irradiation, isolation and confinement, and distance from Earth, and there will be like a gravity fields. So here you can look at in normal the space radiation. The radiation is like a very high, tremendous. I mean, like this radiation is very harmful for any human activities and also for living beings. So this will create yeah, uh, I mean, like it can able to help you this space radiations. I mean, to understand about the Earth like studies, For example, on moon, how you are going to settle the moon settlement on moon, or maybe you are flying into the different space at different altitude, and make sure and how the analogs can able to help you in this. So this will support you to design your electronic equipments. This can help you to protect your protective clothings, and also the space radiation data that will provide you to make sure you can able to withstand and keeping yourself safe inside the capsule. So these are all the activities that can able to do the studies. And the isolation and confinement, and during even the COVID-19 situation, everybody is facing about the co I mean this the isolation and confinement. So this will create you a kind of a behavioral among the group of people in general, and occupying a small space. Like for example, you are inside your home, and you're not allowed to move anywhere unless you have no reason, something like. So there is like no matter how well we trained and how we are behaving, something like. So there are some possible hazards, are like for example, like a decline in your mood and cognitions, and moral and uh, interpersonal interactions, and sleep disorders. Sometimes you may not able to sleep properly, and there will be like called depression and fatigue, and sometimes you may be feel boredom. And the more you confined in isolation, humans are most likely to develop the behavioral and the cognitive conditions. And number three is distance from so the planning and like self-sufficiency are the key. The Mars is 140 million miles from Earth on average, with the communication delays up to 20 minutes, and possibility of the equipments can be the failures, and they must be have the correct food and medicines and the supplies to sustain them during the duration. Number four is the gravity fields. There are three fields like experience on Mars missions, like Taylor between the planets. Like one third of the Earth gravity is on Mars, and normal gravity upon mostly returning to the Earth. There are like possible hazards, are like maybe it affects the spatial orientations, head, eye, and hand, eye, and coordinations and balance, locomotion, and it can cause motion sickness, bones lose minerals, and causing the drop in the density, bone density might be they loosen, and muscles lose the strength and endurance. The cardiovascular systems that become deconditioned, and the floods and the shifts can be put the pressure on the high and cause the vision problems. On other options, like there will be like developing the kidney stones due to the hydrations. And number five is like like environment. Example, environment is like the hostile, and or maybe it can be the closed one. So the ecosystems inside the spacecraft mostly they plays a big role of everyday astronaut life. The microbes can change the characteristics in space, and the microorganisms that naturally live in your body and transferred from more easily from person to person is like a closed habit, like in a space station. Every inch of living quarters must be carefully designed to ensure the comfortable temperature, lighting, and the noise level, and adequate space. And possible hazards, mostly you can see elevated stress, hormone levels, and alter the immune systems, and allergies and illness. So these are the some of the types of the analog missions. Here they listed out. This is like the HERA mission is like the human exploration mission. It is a closed habit mission. It was developed by NASA. It's like the three-star habit designed to serve us like analog isolation and confinement, and mostly in the remote conditions to exploration scenarios. And the Cirrus is in Russia and Moscow, in Institute of Biomedical Problems. They have a base. So here, this is like a closed habit. It's like a multi-compartment facility, and this is a multi-compartment facility. One second, that is some issue. There is like a multi-comparable facilities here, and some of them are Antarctic stations, and some of them are bed rest analogs. Just you have to sleep and start. I mean, there will be like measure the human research activities. I can show you some of the examples of dry immersion testing, so those things. And the radiation analogs are NASA's space radiation laboratories. They used to study the radiation environment, how this can be the radiation factor, how it causes the the development of a space radiation. So they analyze mostly the radioactive substances, and mostly they analyze the risks of I mean the health risks and cosmic radiation studies. They study mostly the why space radiations matters, and so these are the things they will do. And the other analogs, some of them they used by NASA. It's like a Hestia. Some of them Aquarius is like underwater. Some of them are parabolic flights. And Concordia, there will be like desert stations and lake research projects. Some of them into utilizations. So this was the planned previously. It was planned in series 2021, and due to COVID-19 situation, it has been postponed to next year. So I'm likely to participate in the future analog mission of 240 days of isolation mission. It's like a Moon and Mars facility. You can see here the facility of NEK Sirius project. So it's like a compartment. It's looking similar to the space station, and the parameters have been changed like to related to the Mars and also the Moon. So it's like everyone knows about the Soviet Union stand in the world in November 3rd of 1957, the launch of Sputnik 2 on board of the small satellite with a little log like the first animal to the orbit. So this is the created the history, and every nation is trying to build their own space capabilities after the Leica made the historic one. So this is the I'm standing at next to the Leica monument, and it is in Moscow, and the mostly is like the in the picture the Doctor of Medical Sciences, Chief Research Associate in Institute of Biomedical Medicines and Russian Academy of Sciences. They were about to the selecting the animals. The person who's behind the success of like and other the animal space flights and also human space flight is the doctor here in the picture, and he about to experiments with animals and they paved the man into the space. So mostly the general space exploration scenario, like the human presence and expansion of people are trying to go into the Mars. So that's Elon Musk is trying to create the big historic step. So the people are start looking at Mars is like a next destination of the space, something like that. Right now, we are promoting the commercial space up to the International Space Station, like organizing the science space station experiments, and something we can launch your CubeSats and release from the International Space Station, or maybe you can organize the microgravity experiments, those things. And some of the innovative small missions that building the lunar gateway by 2022, there will be like national space agencies are planning to build the international space station, or maybe you can like a lunar gateway operations that is on near to the moon. So the thing is like commercial spaces on the side is growing. The new technologies they are coming up in 3D printing technologies, and some of them are coming forward, and in and also the sample returns missions are many of them. They are planning the sample return missions from the moon and the asteroid there are, and people are trying to land on the moon. Like for example, NASA is trying for Artemis mission, and Roscosmos ExoMars missions also in the line. And the next year they are planning to launch to moon. So there are many activities that are happening around. This is the uh, football size ground of football ground size of the space station. It's orbiting Earth, and every 90 minutes it's pass over. And this was the amazing human engineering. It's turned the world actually, and this is the place. I mean, like U.S. Russia first made it the first space station orbit, and later on many countries followed by U.S., China, Japan, and there are many countries that come forward. These are like they're planning to launch some science missions from in, for example, mini station models or something they are planning by Roscosmos in the next 3 or 5 years. So they have be like a continuous operations in space station experiments. So mostly the human factor engineering. You can see here there will be like the crew selection, and they need to provide the basic training and advanced training and specific training for the specific roles, and later the crew readiness. Once they're ready, they can fly to space. There will be like integral part. It is like the life support systems and flight tools, and next is like the human sciences of bioastronautics. So this like a combined activity of together. So this is how the general human factor engineering has happened. This was photos was taken at like IBMP facilities. So these are like previous analog astronauts candidates that in the picture, the three of them, and Mark is the head of the laboratory, the facility. So I mentioned the human factor engineering as like science without gravity is kind of this is the dry immersion experiment for human factor engineering. This is like a tub. It's like volunteer need to spend 3 to 21 days in immersed bathtub, and it will stimulate the changes of human body experiences in space. And in dry immersion is like a body is supported to eventually without the pressure points. It's much like it will fly floating on the space, something like there are some areas that they needed to focus on. They will check your results that will your eye and your brain activities and ear, your lungs and your muscles and your liver and your bone. So these are the observations that will help them when you are flying yourself to the space. So this is kind of one kind of the experiments. And this is the dry immersion bathtubs. They create the aspects to living the weightlessness on the earth. So these are like volunteer cosmonauts or maybe the test engineers or researchers. They will be take the 6 months to study those the parameters of here. And I always inspired by my real hero, Sergei Vasilievich Agvedev, the cosmonaut. He is flying several times in the space, and even he has created like more than 515 million kilometers. Yeah, I mean he did something like special. Just like inspirations, we always needed to continuous growth and development, develop our capabilities. And we significantly exploration. We are planning for explorations like expanding the human activities that we are planning here. For example, we promote the space industries and we promote the activities. For example, like we have signed some of the cooperation in Russia, like to organizing the International Space Station experiments, that you can fly yourself to experiments that can fly to the space, and you can do the number of researches there. So this is how we are. And nextly, we are exploring the moon. We are planning to launch the smallest rover to land on the moon and to explore and capture the helium, helium and trace the particles of the helium, and we try to extract the helium from there, and send it and take it back to the earth. So this is how the business will go. So there are like a lot of mineral explorations and asteroids and sample returns. We always promote in the industries and inspire the youth. And some of the full-fledged human explorations, like there will be like a 3D printing on moon, or maybe a surface or mining, or remotely controlled automated construction technologies. And some of them is like a 3D bioprinting on the moon. So it's like we are planning to launch the world's first bioprinting on moon that wanted to be demonstrated. This 3D bioprinter was developed by 3D bioprinting solutions in Moscow in Russia. So they made the first, bioprinting experiments in International Space Station in 2018, and still, we are successfully developing the next level of this 3D bioprinter to International Space Station to supply their food. So next is like agriculture technologies, that concept to study the lunar factory engineering, like you can grow your plants and grow your um, vegetables in space. So some of the resources, for example, like Russian orbital segments, that we are planning to configure some of the experiments that you can able to organize there. It's like a small laboratory room in International Space Station. There will be like multi-purpose workstations. It's like a 3-meter cube in size, and mostly zero point 0.3 kilowatt per day. It's like some of the power calculations that we are working, and we are planning for information exchanging the channels that we wanted to place is like 4 GB per second session, sorry. And the delivery and returning of the cargo is yearly. Just we are planning for some 110 kilograms approximately. So there will be like multi-purpose workstations. Uh, it is in general mini research station that we are planning. So here, there will be like a mechanical interface and installation spaces, onboard power supplies, and there will be like a target equipments, the power generations, thermostats. There are. So this name called like Universal Scientific Equipment Platform, that mostly it is can be delivered by Progress or Soyuz crew, or maybe it has some kind of exploit adapter and installation in the facility. So there will be like a different cube sites of the small experiments that we can able to configure it, and the informational results that transferred back from the Soyuz spacecraft. So this is how some of the technical implementations. It is like there will be like 1U and 2U, and there will be like 3U cube size in satellites, and it can be have the remote control panel, and there will be like components, and some of them are projects that can be documented, and prototyping is ongoing. Some of the planned experiments that you can do it uh, something, for example, like experiments on the solutions, exploring the behavior of different water solutions under some environmental like temperatures and influence demotions, and dynamic magnetic fields, mostly the immiscible liquids, dispersed solutions with the magnetic properties, salinities that we can test. Most objective is like collecting the comparative data about the behavior of solutions and technical biological analogs and Earth-like and space conditions. Some of them is like most interesting. It's like green, the cultivation of food plants in mini greenhouse, and the testing of technologies for agriculture and space station environment, evaluation of the cultivated plants and orgoplantic properties, and something. This is like a small greenhouse setup of experiments. There will be like a gas exchange that will like pass over, and this is like ensuring the extradition of psychological support of the crews. So, and some of the planned experiments like a drone, school children's, and
university students, they can develop on small flying robots, as I mean, like, or maybe your friend buddy, something like, it's like a talk active robots, something like, so that we can do it. And so experiment called survival is like, the objective is like to researching the microorganisms resistance to the space flight conditions. It's like to understanding the behavior of materials and organisms under the external environment, changing the gas compositions and pressure and dynamic magnetic field. There will be like something. And the nanosensors, something like the technological researchers for the creative of a new type of sensor devices that are coming to now. We need to monitor of inhabited compartment of gas composition in order to develop the testings sensor devices based on microsensors, analytical softwares, nanomaterials. So this can be used as like to test bed for the space electronics, and also that can be used for the equipment testings. So on. Some of the experiments called component level experiments are technological researchers that exploring of possibilities using the cheap and wide spread of the electronic components. The mostly the commercial electronics components are exposed to the radioactive background and microgravity in ordinary conditions, and developing the health, I mean the testing and health of the sensors and the life calibration and the refinement of the equipments, some of them for testing the electronic chips. This one is like formicarium is like the modes of behavior. The ants are one of the most highly organized social behavior animal, I mean insects. So this is like the social system researching using the example like how the ants can able to perform the activities, and the research on ant family behavior in microgravity experiments and more modes of behavior changing and aspects of living changing and ethereal structure in the microgravity. And this is like the space weather properties like international space radiation background monitoring, and the solar proton events, something like we can register and compare the data. So this will use to understand the space weather near object. So next is like the tracking. The cosmic rays are registered using the digital cameras and the Wilson cloud chamber, something like. The objective is to researching the link between the galactic cosmic rays and the Earth storm activity. So how the both are simultaneously linking together, and how this can be distributed, how this can be creating the storm activity on the Earth. So this will be one of the interesting studies. And the experiments that plan something like the protoplant is like the objective is like the simulation of the protoplanetary is this the growth of space conditions, like researching of different types of surface particles adhesions to big structures of the microgravities, something the bondings of the uh, I mean the behaviors and how the particles can behave in different I mean under microgravity conditions. This is the bioenergy. This was the one of the interesting instruments called technology and prototype testing of alternative power supplies. For example, the movement by walking, by doing the regular activities, so that you can able to power, you can generate the power. It is like, for example, you can walk on the mat, so you can generate the power electricity line. So generating electricity is from the microbial fuel cells. So these devices can be converted into chemical energy to electrical energy by action of microorganisms. For example, like organisms and technologies of testing. So 3D bioprinting solutions, that's our partner company in Russia. So they made the first kickstarting the world's 3D bioprinting experiments that in under microgravity conditions. This was the first experiments that included in the bioprinting of thyroid gland and cartilage tissues can be experimented. You can look at the cosmonaut here. So one is testing by magnetic bioprinter. This name called Argonaut is a part of the scientific equipments that can be used frequently for further experiments. Mostly the 3D bioprinting solutions provide the business to science in international space stations, something called the Argonaut. So here the 3D bioprinting solutions is like the first step is like development and ground testing of magnetic bioprinter, and it wasn't happen. The journey started in 2017, and development of the systems, that technology for the delivery of biological materials to the International Space Station. That was 2017 was done, and 2018 equipment tested for the crew training, and the instruments have been on formative biofabrication of three-dimensional tissues to organ to construct in space under microgravity. It's like it takes some. After that, we took some samples to the Earth, and after the 18 months of the time, so this is like you can see the bioprinter for single experiments, and second is like multi experiments. It's like multi experiment cartridge. You can look at here the step one, the cultivation of cartridge. I mean, like here you can see. Then after that, cartilage and thyroid gland cells. Then after that, the formations of tissues that can be happening around. There will be like the formation of the tissue spheroids, almost like 4 to 8,000 cells in the sphere with the diameter of 200 microns in the form of micro tissue under the fusion. And it will take for 24 hours. And after that, there will be like magnetic bioprinter start functioning, and there was like the maturation of printed constructs to the inside the incubator, and fixation of the samples, and the sending the samples back to the Earth, and analysis of the printed samples on the Earth. And there will be like you can let it cosmic rays. You can there will be like expected some of the experiments that they normally they're in the called in the names in the Russian names called in the they mentioned in the Russian. So it's like a study of the space group behavior loss through the long duration, and immuno is like the investigation of neuroendocrine and immunological changes before, during and after the flight testing, and Matryoshkaya is like investigation into the dynamics of radiological situations throughout the flight course, and there will be like the stations and accumulated mostly the radiation dosage of anthropomic phantom and accommodated inside and outside of the station. And the spirit too is like additional psychological uh, information that extended by the motions of human adaptation to the zero gravity effect. And the chromato mass spectrometer is like investigating the human microbiological status, and the chromophotography and the mass spectrometry method. A motor card is like study of the mechanisms of sensor models and coordinating with the weightlessness. And virtual is like a spatial orientation and interaction of afferent systems in weightless conditions. And plan is like the experiments that features of the structural and functional state of features that different select sections of gastronomic traction to reveal the specific character of digestive systems changes occurring in the space flight conditions. Biocard is the another experiment that investigation of electrophysiological properties and features of the cardiac output change under the functional effects of NBLRP applied in electrocardiogram in 12 leads. The cardiovector is like study of the effect of a space flight factors like spatial energy distribution of the heartbeats and roles of the right and respiratory and left heart of adaptations, and uh, something like to blood circulation systems, that condition for long duration of weightlessness. And cosmochord is like study of the effect of space flight factors in electrophysical characters of myocardium and their relations to the vegetative blood circulations and regulation process in conditions of long durations of weightlessness. Mostly the Morzi is like the monitoring the metabolism and its regulations of dynamics of protective systems of human organisms, ecological factors that during the flight. And Prudent 2 is like investigation of prudentium tissue in state of the space flight conditions. BMIs is like study of information support process of the flight medical support using the telemedicine equipments, it's called. And biosignal is a study of effects of microgravity on intracellular characteristic of functions of the cells. And algometria is like investigation of the pain sensitivity of the human space flight. And Weissmursnowy is like a study of influence of multinational composition of ISS crews, interpersonal skills. There are something. And Dan is the role of baroreceptors and that using the change the activity of central respiratory mechanisms and weightlessness conditions. So next is like content is like content is like a remote monitoring psychophysiological state of the crew, that as well as mostly the intra-group of methods on basis of the comprehensive analysis and communication between the crew and mission control facility. So Corretsia is like investigation of efficiency of aerological and corrections of mineral metabolism conditions under microgravity. And neuroimmunity is like assessments of impact of stress of immunity and stress reactive systems in space that will approach this innovative approach. And movements of the fluids that before and during of after the long duration of flight, and connections of intracranial pressures and visual impairment. And the pilot T is the investigation of reliability of professional activity of the astronauts in long duration flights. And Profiltica is like mechanisms of actions of effectiveness of different methods of preventing distributions of the cosmonaut motor activity in long duration space flights. And SCARCOLAB is like a musculaneously of neuromuscular adaptation of prolonged space flight. And there is like UDOD is like study of the possibility of correcting the hemodynamic changes in the microgravity using the negative inspiratory pressure. We are always continuously inspiring that we work on the Soyuz spacecraft flight simulators that you can fly yourself. That is, we give an opportunity to fly yourself, to fly to International Space Station, to feel like a cosmonaut. So now, normally we are proposing the simulator. What we are doing is the simulator is intended for educational entertainment purpose, and also in the same time you can install it anywhere in your laboratory or at home or maybe in the museums to practice yourself, fly yourself, and to the International Space Station, flying around the International Space Station, something like that. So this will be the thematic scenario you can see here. This is the Soyuz spacecraft, the full size of the spacecraft, and this was like educational level simulators that is based in Zhukovsky in Moscow. So we offer the training and the kind of educating, Soyuz professional education in training of the simulators. And some of the pictures here, you can Sergei Kirkulov is also the practicing the simulators here, and there are like previous Prime Minister of Russia, Mandel. They are like it's kind of I mean, like education at the same time entertainment, and also we are adopting the digital transformation technologies that people can easily to understand and to start studying this activity. And we are planning to place this kind of this Star Trek kind of environment that we are planning to give, and the students can come and learn the activities something here. And next legacy is waiting for the Roscosmos is planning for the pressurized human landing on the moon. So there are a lot of things that are happening around. So we continuously actively exploring the participating in space exploration. We always realizing the challenge of the missions and based on the necessity and also the goals of the organizations. The Wells, Marineris, and Synergy Moon, and we are working together like internationally and in Aviacom in Russia and S7 Space, and there are like many other international players. They're all supporting to diversify the background and start building the new ecosystem, space ecosystems in Russia and also in India and globally. Mostly the international frameworks that stimulate the discussion for coordinating the creating the cooperations. Maybe you can exchange the academia level, industrial level, and human explorations beyond the Earth, something like so. We are happy and support with you all. So that will be like get yourself, prepare yourself, get into the space. These are some of the first steps from the exploration to the development of your small experiments that you can fly your experiment in space that will create you amazing experience, and you will be something really doing something you can stand alone doing the other researches. The space is always the fascinating, and space exploration is like be like the mostly kind of the new innovative concepts and new technologies and new solutions and new problems, and there will be like many activities that you can able to lessons you can learn. So this is kind of a very thrilling, and known I have been experience very limited people can able to experience those things. So some of the interesting things, if you have if you want, you can fly, you can contact us, so you can fly yourself to the space. So, and CIS, we are planning for the lunar explorations and moon mining. There are some of the experiments that we are following, and these are my contact information. People can write to us, and we are happy to support them. And some of them, this is like the lunar exploration spacecraft that's behind on the screen, and this is the smallest rover that can move on the moon. So this is the thing. Thank you very much. And some of the training of recent, I mean, human exploration research, the training of participating cosmonauts, as like on one conditional crew is like recent current cosmonauts are undergoing the training to before, I mean, like checking, preparing yourself to the space. Some of the hydro laboratories, it is in Star City. Some of the areas, the students and participants, the listeners, they can visit the Star City and the national museums in Russia. So you can explore your space activities and to understand the space innovations. So you can make yourself flying just like that and future cosmonaut, something like really that. That's it. And thank you for listening. And wish you thanks for joining the big celebration of All Russian Science Festival, Krasnoyarsk Cry, and we are happy to be take part in the journey of 15 years of All Russian Science Festival. And thank you very much. And we look forward to discuss with you all. And you can write any questions if you have any questions. Please write my email. I can respond as early as. And you can contact us for exploring yourself, putting yourself, exploring science experiments. If you wanted to organize an international space station, feel free to contact us. And thank you very much. And thanks for the opportunity and for thanks for our colleagues for moderating the wonderful session, and thanks a lot.